Alright, so we're going to run through the elimination method again, but I want you to notice the coefficients for the x variable are not the same. The coefficients for the y variable are not the same. So first off, I'm going to have to pick which variable I want to get rid of, either x or y. After that, I'm going to make those variables additive inverses. Well, I'm seeing here I have subtraction of 3y, and below I have subtraction of y. If I were to increase this variable y 3 times, well, I'd have 3 and 3, or 3y and 3y. So my goal is to eliminate the y variables in this problem, and I'm going to increase this y variable 3 times. If I do it to this variable y, I've got to do it to the entire equation. So I'm going to put parentheses around the entire equation, and I'm going to multiply by a 3, but I want to know, is it a positive 3 or a negative 3? I'm going to move all this information over just for a second, just so we have a little bit more room. Since I want to make the y variables additive inverses, and I already have subtraction of 3y above, I'm going to need to turn this subtraction symbol into an addition symbol. The only way to do that is to multiply by a negative 3. So now negative 3 will distribute into each of these terms, and I'm going to rewrite all of this information below. So for the first equation, we have 4x minus 3y is equal to negative 9. Now I'm going to rewrite my new equation below that. But as I'm writing the new equation below, I'm going to align all of the terms in both equations. So negative 3 times 5 will give me negative 15. So I have negative 15x. So negative 3 times y will give me negative 3y. But there's a subtraction symbol in front of it, so I'm going to use double dash and turn that into an addition symbol. So now I'm adding 3y. That's equal to negative 3 times 8 is negative 24. So now I'm actually just going to put parentheses around that negative 15x, and I'm going to put an addition symbol way off to the side here. So we have 4x plus negative 15x. Another way of thinking about it is 4 minus 15. That's going to give me, I'm going to change pen colors, negative 11x. Now I have 3y here, but you've got to think about the operation to the left of it. So I have negative 3y and positive 3y. They're additive inverses of one another, so they'll cancel out. So negative 11x, it's equal to negative 9 plus negative 24 will give me negative 33. So if you want to, you could rewrite this below so it's a little bit neater. So you'd have negative 11x equal to negative 33. And I'm going to divide both sides by negative 11. I'm left with x is equal to positive 3. I'm going to substitute positive 3 back into one of the original equations. I'll use this second equation here. And I'm actually just going to draw an arrow. I'm going to do that work right over here. So I have 5 times 3, close parentheses, minus y is equal to 8. All right, I'm going to change colors. So now I have 5 times 3, it's 15, minus y is equal to 8. Okay, so now here, just take a look here. I have 15 minus y equals 8. The overall goal is to have a positive variable, so to isolate the variable and have it be positive. Well, my next step, when I get rid of 15 on this side of the equation, I'm going to be left with the negative y. So if you're wanting to at this point, you could multiply straight through this equation with a negative 1. That would ensure that y would be a positive variable when you isolate it. Just be careful if you choose to do that. Make sure you change the sign of each value in this equation if you do that. Alright, so I'm going to subtract 15 from both sides. And now I have negative y is equal to 8 minus 15 is negative 7. But I have a negative variable, a negative y, and I want it to be positive. So again, a couple of ways of thinking about this. Just change the signs of all of the values in the equation. So I'm going to turn this into a positive y. That would turn this into a positive 7. That's the quick trick. And I want to show you why that's the case. There's a value hiding in front of the y here. It's 1. So you could think about this as negative 1 y. If I want y to be a positive variable, all I'd have to do is divide both sides by negative 1. I'm going to just backtrack for 1 second. If you don't want to divide both sides by negative 1, think about it as just multiply straight through with negative 1, and negative 1 times negative 1 would give you positive 1. Negative 1 times negative 7 would give you positive 7. I'm going to backtrack again and continue dividing straight through by negative 1. Still, in the long run, we're left with positive y is equal to positive 7. All right, so the solution is 3, 7. And I'll box this information up. Cool stuff.